Welcome to solverfy.
More problems on friction. Consider the system shown in the board. Okay, we want to determine what minimum force can lift that load that is on top there. All right, the 3000 IV load. So what we can do is to consider equilibrium of the system, uh, of the first diagram at the top, and of the second one, the one at the bottom as well, and solve the resulting equations to get a force. So if we take consider summation of forces in the horizontal direction, we are going to arrive at Fx is equals to 0, so that we have Nb, where Nb is the normal reaction at point at B, sine 15 degree. Sorry, the plane is inclined to 15 degrees. Okay, or the wedge or whatever is inclined to 15 degrees plus Fb is the frictional force at B cos 15 degree cos 15 degrees okay, minus Nd, the normal reaction at D is equal to 0. When we plug in all our values into uh, this equation, of course, mu is given, that's the coefficient of static friction for the different surfaces that are contacting on each other where friction is taking place. They are given. Okay, so you need to know when you bring out this one, you're going to arrive at 0.26 n nb plus 0.29 nb minus nd. Okay, it's equal to 0. So we can just call this equation 1. Okay, then we can also consider equilibrium in the horizontal direction, sorry, in the vertical direction. And we'll do that. We're going to arrive at this, that the summation of the forces will be minus, okay, Fd minus 3000, okay, plus Nd normal react, sorry, Nb, this Fd is frictional force at D, Nb is normal reaction at B, okay, get that, cos 15 degrees minus Fb sine 15 degrees is equal to 0. Now when we bring this one out, we're going to arrive at 0.97 normal reaction at B minus 0.1 normal reaction at B minus 0.3 normal reaction at D minus 3000 is equal to ze- to 0. So you can call this equation 2. Now, when you solve equation 1 and 2, you are going to arrive at your NB, the normal reaction at B. You're going to have it to be equal to 4, 4, 4, 4, 7, 7.6 IB, and you are going to arrive at your normal reaction at D, point D, to be equal to 2910.4 IB. Okay. Now we can also consider the bottom diagram. When you consider the bottom diagram, we look at equilibrium in the vertical direction. You're going to arrive at okay. You're going to arrive at minus NB okay. You're going to arrive at minus NB cos 15 degrees plus FB. Of course, FB will be converted to mu NB because okay, cos 15 degree plus FB. So you convert this one, knowing that frictional force is mu. That's the coefficient of friction times the normal reaction sine of 15 degrees plus NC is equal to 0. Okay. Now, when you solve this one, you are going to arrive at NC to be, of course, we know the value of MB already. So you plug them in there from the previous, you're going to arrive at NC to be equal to 3861.43 IB. And of course, we can also look at summation of forces in the horizontal direction. When we do that, we are going to arrive at P, which we are looking for, to be equal to FC, frictional force at C, which will convert to normal reaction at C, okay, times the coefficient of friction there that applies cos 15 degrees minus MB sine 15, sorry, sine 15 degrees is equal to 0. When you do that and solve this, you are going to arrive at your P to be equal to, plug in all the values you've already gotten previously. You're going to arrive at P to be 4047, okay, 7.34 4IB, which is equal to 4.05. That so that's the minimum force.